Hello. This is a proposal for developing scalable and cost-effective methods for super hydrophobic coatings on cotton textile. My name is Prithviraj Shaw and these are my contact details. First of all, what is hydrophobic coating? If you know this part, please feel free to skip it. For starters, watch this. Super hydrophobic coatings make a surface extremely repellent of water. This makes it self-cleaning and stain resistant. There are many commercial formulations of such coatings. Many formulations have been researched, but none have been used commercially due to some inherent limitations that we will see further. A surface is defined as hydrophilic or hydrophobic based on the contact angle between solid and liquid. For superhydrophilic, this angle is less than 10 degrees. For hydrophilic, this angle is less than 90 degrees. For hydrophobic, this angle is greater than 90 degrees. And for superhydrophobic, this angle is greater than 150 degrees. In nature or in synthetic process, whenever we want to make a surface super hydrophobic, we make it by making hierarchical nanostructures, as you can see in this picture. So what are the current problems with coatings formulations? Before we dive into that, a few words on cotton fiber itself. Cotton fiber is made up of cellulose strands. This cellulose is made up of glucose monomer, but the repeating unit is this, as you can see. Cellulose has OH groups which can be used to graft other molecules, altering its properties. The interaction of OH groups gives its characteristic strength. Till now, nanoparticles of SiO2, TiO2 and ZNO has been employed to successfully make superhydrophobic surfaces, but nanoparticles will be washed away if the clothes are washed. Moreover, nanoparticles are toxic to the cells as they may do DNA damage, leading to apoptosis in body. Nanoparticles may also pollute the environment and cause irreparable damage to the microbiome. Polysilenol and similar molecules with halogen, thiol or amine groups have also been researched. Polysilenol is a non-toxic and gives high contact angle by forming around 1 nanometer protrusions on the cellulose fiber. This material is usually made by dehydration of OH groups of polysilenol and cellulose, forming an ether bond, amide bond or similar bonds. But these class of materials are usually washed away after a certain number of washes, and the decrease in contact angle can be noted from the first wash itself. This happens due to the cleavage of cellulose and polysilenol bond due to hydrolysis during washing. Another interesting approach has been use of silsesquioxane and polyane substituted variations of molecule. Polysilanes can form cross-linked structure which may be strong enough to withstand hydrolysis of COSI bond. One such method was demonstrated using formation of silsesquioxane molecule. But this method is very inexpensive as it uses expensive precursors, expensive solvents, and elevated temperatures. So to see the problems at a glance, the current formulations are toxic, not washable, and expensive. So what is the proposed solution now? The big idea is others have used OH bonds on the cellulose to anchor other molecules, forming an ester, ether, amide or other bonds. Or in general, there is a cellulose and then the other long chain molecule is attached via the O bond. This ether-like bond gets hydrolyzed after every wash. No one has directly attached a large molecule like DTMS or decane directly to the cellulose. So cellulose directly attached to a long chain molecule. Directly connected molecules cannot be hydrolyzed during washing. So the approach that I propose is we can treat the cotton fabric with HBr first and then make it react with decane, which has already been made a carbocation by reacting with NaNH2. So you have cellulose, it reacts with HBr, the OH is replaced by Br, and then we use a decane carbocation and the Br is replaced by decane such that decane is directly attached to the cellulose fibers. We can tweak the reaction parameters like temperature, concentration of HBr, NaNH2 and decane and reaction time to get hydrophobic surfaces without loss of strength of fibers. So to achieve this, we will have to do certain experiments and investigation. I have explained it as we go. So first step will be synthesizing cellulose and decane. Treat the cotton with HBr. Check the FTIR to see if the bonds that we expected are present. Then treat it with decane, and then again take an FTIR to see the change in bonds. Then we can change the reaction parameters and repeat it to get different to get samples of different reaction parameters. So we will have to do FTIR characterization of cellulose decane, sample preparation, check if required bonds are present, and then label report. Contact angle measurement, receive labeled samples, measure contact angle, wash, and then again measure contact angle. Do this several times to get some trends on how our new hydrophobic substance is performing under the ASTM standards of washing. Next, we will have to take some SEM images. So receive labeled, washed and samples, sample preparation, get SEM images and then report findings. It is good to know that resolution of SEM is 0.5 to 2 nanometers and decane length will be of 1 nanometer. Then we can take some of the best samples and do TEM, receive the best labeled washed or unwashed samples, sample preparation, get TEM image and report findings. Resolution of TEM is around 0.1 to 0.2 nanometers and decane length is 1 nanometer. So we should be able to clearly see the uh, decane on the cotton fibers. Finally, we will have to do some tensile tests as well. So receive the best labeled unwashed samples, get stress strain curves of all samples and then report findings. This is important because of the precaution that I'll tell you later. There is an important precaution that we need to take is that HBr can react with glycosidic linkage of and hydrolyze cellulose into smaller cellulose fragments. However, this reaction happens at elevated temperatures of around 100 degrees Celsius and reaction times of 2 to 4 hours. Desired reaction time and concentration of HBr and temperature for making super hydrophobic coating needs to be investigated. We will have to keep our temperature and reaction time less than this so that only the surface of the cotton gets reacted with HBr and the bulk of cotton fiber is not affected by it, thus retaining the strength. Finally, these are some references that I used. I highly recommend you to check this out. And finally, thank you for your interest. Any feedback will be highly helpful.